So, this is the Euler's equation along a streamline. Now, with the help of this Euler's equation, we can write the Bernoulli equation for steady incompressible irrotational flow. So, keep this thing in mind. We will go for the derivation of the Bernoulli equation for ideal fluid flow along a streamline. So, this is a V del V dV over ds is equal to minus 1 over rho del P over del S minus G dz over ds. For steady flow equation, that del V over del T term has gone. So, from that equation we can write this equation for steady flow, right. Now, this is a flow along a streamline. So, if we want to integrate over a certain segment of the length of the streamline, then multiplied by that segment of the line and integrate over that length, then this equation can be written in the form of integral of V dV over ds into ds is equal to minus integral of 1 over rho dP over ds into ds. So, here we have term ds also, ds line segment. Now, if we integrate, then this term will become v square divided by 2 and this term will become dP over rho integral plus g z is equal to constant of integration, right. So, if we integrate for line segment of length ds, the Euler's equation becomes this one. Now, if we have a incompressible fluid, then rho is also constant. So, rho can be taken outside the integral sign and dP may be written as P. So, this equation can be written in the form of P over rho plus V square divided by 2 plus Gz is equal to constant, right. And we can write it in another form P over rho g by dividing it by g, P over rho g plus V square divided by 2g plus z is equal to constant. Now, if we look at this equation, then this term P over rho g is known as a pressure energy, V square divided by 2g is known as a kinetic energy and z is known as a potential energy. So, with the help of this equation, we can state that for steady incompressible irrotational flow along a streamline, summation of these energy, pressure energy, kinetic energy and potential energy will remain same along the streamline. Now, if you look at this equation into further details, then we can observe then P over rho g is nothing but it is a pressure energy per unit weight, V square over 2g is nothing but it is a kinetic energy per unit weight plus z is nothing but it is a potential energy per unit weight. So, these potential energy per unit weight is a head, this z if we do the dimensional analysis it is in meter, and if we do the dimensional analysis of V square divided by 2g it will come in terms of meter, and P over rho g also will come in terms of meter. So, all these three terms are in meter form. So, this is basically kinetic energy, pressure energy per unit weight, this second term is kinetic energy per unit weight and third term is potential energy per unit weight. Summation of these three will be same along the streamline. Now, we have studied about these two type of energy, kinetic energy as well as the potential energy, but this is new term to us relatively, this P over rho g. So, what is the significance of P over rho g? To understand this, let us take one example. Suppose we have a ball of mass m, and if we drop this ball on the surface, then it will follow this path. At any point, if we want to know what is the combination of potential energy and kinetic energy, we can say, and then it will fall. So, at any instant, at this point, at this point, at this point, or at any instant in terms of time also, we can say what is the kinetic energy in that ball and what is the potential energy in this ball. So, this ball when it is dropped from certain height on the free surface, then this ball possesses the potential energy as well as kinetic energy, but we have not come across with this term P over rho g. Now, to understand this P over rho g terms, let us assume that we have a pipe. This pipe, at the bottom we have a tap to control the flow rate through this pipe, and at the one end of the pipe, which is situated in a perpendicular direction, or overhead tank, let us say this is a overhead tank in which water is filled up to this height, right. Now, if we open this valve, then fluid will starts moving in this direction. Now, this fluid will start moving in this direction, but these particles at this point, they are having more potential energy in comparison to particles just beneath to that fluid. So, this one is interested to move with higher velocity in comparison to this one, but since these particles are not allowed to move downward with their own velocity, because this fluid flow is restricted. So, because of these restriction, these fluid particles having different potential energy are not supposed to move with the desired velocity because of the restriction. So, pressure energy is nothing but it is a one kind of flow energy, or it may be termed as it is one kind of potential energy Z. It is one kind of potential energy ready to be converted into kinetic energy, right. In this case, this potential energy of this ball, if we drop it, it is getting converted into kinetic energy, and this ball movement is not restricted, right. But in case of fluid flow, there is a restriction. So, potential energy is basically, we have a potential energy along with the pressure energy. So, pressure energy is nothing but it is a kind of potential energy ready to be converted into kinetic energy. That is why P over rho g, or rho g is written as sometime W, weight density of the fluid. So, pressure energy plus g is called piezometric head, right.